Hello, this is Mr. Stansbury. I'm going to take you through the notes on areas and volumes of similar objects. At the end of this, you should be able to say, I can use the properties of similar objects to find area and volume of similar objects. Okay, so first thing, if a two-dimensional object is enlarged with a scale factor of k to produce a similar object, the new area is going to be k squared times the original area. Okay, now what that means, let's say, for example, we've got a, let's just say we got a square here, okay? And let's just say, for simplicity's sake, 1 centimeter by 1 centimeter. So the area of this thing here is going to be 1 square centimeter. Now let's say if we've got another square over here, and let's say, even though I didn't draw this to the right scale here, let's just draw it to at least a somewhat close scale. Okay, let's say that this thing here, pretend that that's a square. Let's say that this is 3 centimeters by 3 centimeters. The scale factor on this, scale factor, is going to be 3, right? Because you take this side, multiply it by 3 to get to that side, this side, multiply it by 3 to get to this side. So when we find the area of this, 3 times 3, the area is now 9 centimeters squared, right? So what this up here is saying is the area is going to be the scale factor squared times the original area. So in this case here, the area is going to be the scale factor, which is 3, squared times the original, 1 centimeter, sorry, the original area. Okay, so 3 squared is 9 times 1, area is 9 square centimeters. So you got to take your scale factor and you can't just multiply it by the scale factor, you got to multiply it, because it's 2 dimensions, so you got to convert it. You're using the scale factor twice, so you got to square it. Okay. Same thing here with a 3-dimensional object. If a 3-dimensional object is enlarged with a scale factor k to produce a similar object, the new volume is going to be k cubed times the original volume, because now you have not just 2 dimensions, but now 3 dimensions, so k cubed. Okay. Let's take a look at some examples to help clarify this. Okay. Triangles ABC and XYZ are equiangular, so therefore they have to be similar. If AC is 12 meters, so AC, this is 12 meters. Oops. Let's do that in a different color. 12 meters. XZ, this one right here, is 9. Well, 12 meters and 9 centimeters. Let's do this. Let's make this 9 meters. Okay, and the area, oh, these are all centimeters. Let's just change these all to meters then. Okay, and the area of triangle ABC is 125 square meters. Find the area of triangle XYZ. Okay, so we know these are similar. So to find the scale factor, let's see, we know that this one here is 125 square meters. So to find the scale factor, or simply scale factor, take what we know, which is 12. Right, 12 is 12. You got to sorry. Let's do this instead of putting 12 on the top. Let's see. We ended up with 9, and we started with 12. So let's do this. So we know that we have to take 12 and multiply it by something to get 9, right? So let's do this. Let's do 9 over 12, which equals 3/4 or 0.75. Okay, so 0.75 is our scale factor, because 12 times 0.75 is going to equal our 9. Okay, so there's our scale factor. Always want to have the image is going to be your numerator, and your pre-image is going to be 12. So what you started with and what you ended with. Okay. So with that, we know our scale factor is 0.75. So now we have to figure out the area of this here. Okay, so we have, it says in our formula that the new area is going to be the scale factor squared, and our scale factor in this case is 0.75 squared times the original, which is 125 meters squared. So then our area will then be, so we do 0.75 squared times 125. So then our new area is going to be 70.3125. First, second, third significant figure. 1 tells us 3 to stay the same. So let's go with 70.3 square meters. This one is smaller than this one, and then this area here is smaller than that area, so feeling pretty good about that. Okay, let's take a look at another one here. Given that figures A and B are similar, find X. Okay, so now we know that, let's see, they actually give us the two areas, and then they give us a side, and we got to figure out what this side should have to be. Okay, so again, our scale factor is going to be x over 30, right? Because we're going to end with this one, so we put x over 30. So can't really simplify that, so let's just leave that as x over 30. And so if the original is 72 centimeters, and the new one is going to be 140, so let's do this. It said that the new area is always equal to the scale factor squared times the original area. Okay, so let's just plug in all the stuff we know. So we know that the new area, that's the second one here, is going to be 140 centimeters squared. That's going to equal the scale factor, which we don't know, but we can put x over 30, square that, times the original area. Oops, we know what the original area was, so we don't have to do that. Original area is 72 square centimeters. Okay, so now we just got to go through and solve this thing for x. So remember, reverse order of operations tells us that we have to get rid of, we want to solve for x, so we got to get x all by itself. So we got to get rid of this times 72. So multiplying by, to undo the multiplying, we divide by 72 both sides, right? So we get 140 divided by 72 gives us 1.94. 0.944, repeating, equals x over 30 squared. Okay, so we got rid of the 72. Next thing we got to get rid of, x over 30 is attached together. We got to get rid of that squared. So we got to square root both sides, right? So then we'll have x over 30 is equal to, so look, there's our 1.944. So we got to take second square root, second answer. So it's going to take the square root of our unrounded answer, which is very important. Make sure that you don't round that off. It'll start messing up your answer a little bit. So we get 1.39443, so forth and so on. So 1.3944 dot dot dot. Okay, and then our last step, multiply both sides by 30. All right, and then that will tell us what x has to be. So again, we still have that 1.3944 unrounded number in there. Multiply that by 30, and we get 41.833. First, second, third significant figure is 8. 3 tells the 8 to stay the same, so 41.8 is centimeters is going to be what that length there is. Okay, that's a little trickier. But again, if you just use your formula, use this formula here, that, and then just plug in all the information that you need, and you can just go through and solve, and away you go. Okay? All right, let's look at one more. Given the following similar objects, find the unknown value. So, oh look, now we've got a couple volume problems here. So, we know that, let's see, let's find we can use this to find our scale factor, right? So I'm just going to start with the second one. 9.5 is to 3. 9.5 divided by 3, that's going to be our scale factor, right? So 9.5 divided by 3 gives us 3.166. Right, there's our scale factor. And then if you'll remember our little formula back on the previous, the beginning of the notes here, had that the new, and in this case here, the new volume is going to equal the scale factor, since it's volume, it's 3 dimensions, cubed times the original volume. Okay, so original volume on this is, let's see, we'll start plugging in information here. How about this? New volume, we don't know. That's X. Scale factor we know is 3.1667 cubed, and then the original volume is 14.1 cubic inches. Okay, so now all we got to do is just calculate that. So we got the 3.1667 is still in there. So let's just do this. We can do to the, and look, it's going to automatically put your answer in there. So we're going to cube our answer, and then I got to push the arrow over here to get back out of the power section there, and then multiply by 14.1, and that should tell us what the volume of this basketball should be. 447.74. First, second, third significant figure. 7 tells the 7 to get bigger. 448. So the X equals 448 cubic inches. Okay? All right. This one here, we again want to start with our scale factor here. So we start with 20 and we go to X. So X over 20 is the scale factor. All right, start with what the image and then divide by the pre-image, so X over 20. Okay, and then let's see, again, we know here's our formula right here. It's cube, sorry, cut it off. The new volume we know is 290 cubic inches. The scale factor here is X over 20. And we have to, since it's volume, we now have to cube that and then multiply it by the original volume, which is 120 inches cubed. Okay, so now we got to solve this thing. So just like we did on the previous example, divide both sides by 120. All right, 120 inches cubed, those go away. 290 divided by 120. 290 divided by 120 gives us 2.4167. Right, and that is our scale factor cubed. Right, so that's X over 20 cubed. So we got a cube root to get rid of that cube, right? That will turn this into just X over 20. So we got to now take the cube root of this 2.41667. So let's see, the cube root on this one here, I believe, is going to be under the math. So we can actually just do math, and there's an actual cube root here, or you can do the X root, like if you need to do fourth root, fifth root, 10th root, whatever, you could use that, but we just need this one. So we're going to take the cube root of our answer, right? And that's going to give us 1.3419. Right? And then our last step is to multiply both sides by 20. And we get X is going to equal. So we just take that answer, multiply by 20. Remember, we really don't want to round anything off until we get to the very end. Okay, 1, 2, third significant figure is 8. The 3 tells the 8 to stay the same, so 26.8. is our x, which is in this case inches. Okay? All right, that's all there is for this here. If you have any further questions, please feel free to ask in class. Thanks.